Have you ever stopped to think about what makes a fighter jet truly dominant in the 21st century? Is it just speed, stealth, firepower? Or is there something else, something invisible that holds the key to air superiority? We often imagine dogfights as a purely physical chess match played out at Mach 2, but the reality is far more complex. Today's most advanced combat aircraft, like the F-22 Raptor, are not just flying machines, they are flying supercomputers. And like any computer, they are a target. Welcome back to Skyjet Wings, everyone. It's great to have you here as we peel back the layers on one of the most secretive aspects of modern air power. The very idea of hacking a fighter jet mid-flight sounds like something straight out of a Hollywood blockbuster. Yet, this is the new reality that military planners and engineers grapple with every single day. The F-22 Raptor is a marvel of engineering, but its immense power relies on millions of lines of code. So how does the F-22 actually defend itself against a cyber onslaught? The answer lies in a design philosophy known as defense in depth. This isn't about a single magical firewall, it's about creating multiple redundant layers of security, making it incredibly difficult for any single attack to succeed. The first layer is physical and architectural. The F-22's core systems are built on what is often called a closed architecture. This means its most critical flight and mission systems are intentionally isolated from external networks whenever possible. You can't hack what you can't connect to. It's the digital equivalent of an air-gapped computer, kept separate from the internet. This isolation is a fundamental design choice. While the F-22 needs to communicate, its systems are not built like the open, easily accessible networks we use in our daily lives. The data links it uses, like the Intraflight Data Link or IFDL, are highly encrypted and proprietary. They are designed to be low probability of intercept, meaning they are incredibly hard for an enemy to even detect, let alone decipher. Think of it as a secret conversation whispered in a unique language that only other F-22s can understand. The F-22's cyber capabilities are not purely defensive. This aircraft is not just a digital fortress, it's also a digital hunter. One of its greatest strengths is its ability to operate as a powerful sensor node, passively collecting enormous amounts of electronic intelligence from the battle space. Its AN/APG-77 radar and AN/ALR-94 electronic warfare suite are not just for finding and tracking targets, they are also incredibly sophisticated ears, listening to the electronic emissions of enemy aircraft radars and communication networks. This is where the line between traditional electronic warfare and cyber warfare begins to blur. The Raptor can use this information to create an unparalleled picture of the electronic battlefield. It can identify and classify threats long before it is ever detected itself, but it can go a step further. While officials are tight-lipped about the details, it's widely believed that the F-22 possesses capabilities to actively disrupt, and perhaps even deceive, enemy systems. This isn't about a brute force jamming signal that simply overwhelms a frequency. The critical importance of these cyber defenses cannot be overstated. The F-22 Raptor was designed for one primary mission, to establish and maintain air superiority, going into the most heavily defended enemy airspace, clearing the skies of any and all threats, allowing other less stealthy aircraft like B-2 bomber F-35 strike fighters to operate with relative freedom. If the F-22 systems could be compromised, this entire strategy would collapse. The tip of the spear would be blunted before it could even strike, with potentially catastrophic consequences for the entire operation. Think about the trust a pilot must place in their aircraft. They are flying at the very edge of performance, relying on helmet-mounted displays and cockpit screens. That data must be pristine. If a pilot cannot trust their sensors. Looking ahead, it's my personal opinion we are standing at the dawn of a new era in military conflict. The dogfights of the future may be won or lost long before two aircraft ever come within visual range of each other. They will be fought in the electromagnetic spectrum, algorithms' advanced data links serving as the primary weapons. An aircraft's ability to defend its own networks while simultaneously disrupting its opponents and neutralize threats in microseconds. Future fighter pilots will need to be more than just skilled aviators. They will need to be systems managers, capable of understanding and fighting in a complex digital environment. The future is already here. I encourage you to stay curious, keep learning about these incredible technologies, and continue to follow us here at Skyjet Wings.